Hi everyone, my name is Nastran and I'm going to talk about the workshop number 6 using Patran. This is the continuation of the workshop number 5 that I talk about later during these videos. So here's the analysis of the piece we made in the last workshop, so let's begin. In order to begin, we need to open our folder with where our last workshop were. So we go to number 6 and we open our Patran. Here we will continue developing the analysis, the structural analysis from this frame, or for this frame in this case. Here you will create a finite element model. You will apply dead loads, you will apply operating loads and gravity loads using constraint nodes, and you will use for an intermediate difficult frame system. You will perform the analysis of the model and post-process the results from the analysis. We're looking for deformation, one meets the strength range, and marker tensor using two different coordinate systems and transformations. So first of all, we'll go to File, we go to Open, and we select Sort Create Part 2, that is a continuation of the workshop number 5. So we hit OK, and here we have the complete part. So for our next step, we will go to Create, here on Group, Create, we will select the group name, we will select frame underscore surfaces and we'll select apply. And we'll select apply and then we'll select change. Okay, so we'll go to the meshing tab. We will create mesh and it will be a surface. It will be quad. We will use Paper and we'll use quad 4. Here we'll select the surface list. We will select the complete thing we're working on. And with the global edge length, because we have the student edition, as you can see, we will uncheck the automatic calculation and we'll put 2.0 to work with, and we'll hit apply. That will create the mesh we were working on, and we'll continue for the next step. So for the next step, we'll go to equivalence as well. We'll put the object as all, and the method will be tolerance cube. So here we'll check that the equivalence tolerance is in 0.005, and we'll hit apply for the next step. Here we can continue. You can see it will change the way you're seeing the mesh, and you will go to verify. Here in action you will go to verify, you will go to element, and you will go to boundaries, and you will select display type as free edges, and you will hit apply. You can see here are the edges and no things open, so you can continue with your next step. Here you'll go to verify, and the thing you will change for the thing is named quiet as an object, and you will have aspect as the thing of test. You will go and have an aspect ratio of 5.0, and you will hit apply. You will select the highlight only as well and color code elements, and you will hit apply. You will select here because the license we're having, but we'll select OK, and you can see how the colors are applying in order to see the complete aspect. And then you continue, you will go to post everything group, and you will select all surface, and you will hit apply, and then cancel. So you will go to and put the smooth shaded optic. You will zoom to this area, and you will select the loads and constraints, and you will create here a force, and you will use a nodal. You will put the name as the underscore load, and you will put input data. You will put a force of 0, -1, 5, 0, and 0, and you will hit OK. And in the select application region, you will select these 2 points. You will be in geometry as well. You will select point number 3 and point number 60, and you will hit OK. and you will hit apply. Because here the loads are the ones that are showing, so you're in the right way. Then you will continue and you will go to home. You will put here that is feed view, and you will go to this part this time. So you will go to here, you put that load underscore 2, and you will go to input data. You will erase this force and you will go 0 minus 960 and 0 again. You will hit OK. You will hit select application region, and you will select this point, that is point number 37, and this point that is number 80, and you will hit OK, and you will hit apply as well. You can see here the 2 points, the 2 forces are created. Then your complete picture needs to look like this, and you can continue. You go as well as here at create force and nodal, and you will erase this set name and add a new name called OP underscore static underscore load. You will select the input data of 0 minus 100 minus 100, and you will select OK. You will select application region, and you will select geometry, and you will select as well as 0.37 and 0.80. You will hit OK, and you will hit apply. Then the picture will show like this. You can hit it in field view, and you can see it like this with the 4 forces acting. Then you will put to here forces as well, loads and PCS, and you will create a force, and here will be an inertial load, and it will be element uniform. You will the new set name, it will be gravity, and you will enter input data as transaxle of 0 minus 386.4 and 0 as well. You will hit OK, and then you will hit apply. For our next step, we'll go to create, it will go to displacement, and we'll create type nodal, and we'll set the name as fix underscore base, and select input data of a translation of 0, 0, 0, and we'll select OK. So once we hit apply, you will see here in existing sets, it will say fix underscore base, so you can continue with your next step. For your next step, you will go to select entities. Then we go to select application region, and you will go to this point, that is point 52. You will say add. You will go to this point, that is point 98. You will say add. You will go here, you can select view, and you can go to this point, that is point 1, and you will go to this point, that is point 90. Then you will hit OK, and then you will hit apply. So you can see here there is 1, 2, 3 in every corner. And then you go to your next step. You go to display here. You will go to load DC element props, and you will uncheck the one that it says show LBC L probables. You will select that one, and you will hit apply and then cancel. It will look like the following. You can see here is a new bar, a new thing appearing. So you will go to properties, you will go to materials, you will go to create. Here in isotropic, you will go to create isotropic. Now input, you will go as a material name aluminum, and you will input properties and elastic modulus of 10E6, opacitance ratio of 0.3, and a density of 2.61 E minus 4. You will hit OK, and then you will hit apply. You can see here that the aluminum has been created. Then you go to your next step. You go to create. It's here create. You put it in 2D and you will put it as a shell. And you will go to property set name. You'll add the name of frame underscore flange here, and you will go to thing homogeneous and standard formulation. Your input properties, you will select the material name as aluminum, and you will go with a thickness of 0.75, and you will put OK. Then on the select application region, you will go to home, you will select this orientation, and you have the two flanges here. So you go to preferences, you go to picking, and then you will select enclose entire entity, and you will hit close here, and then you go to select application region. You will hit this flange, add, and this flange. You hit add. So you said OK, and you hit apply. You can see here the frame flange has been applied. So your next step, you will go again to preference, picking, and you will select enclose any portion of entity. You will go as well with close, and your property set name will be all underscore frame underscore web. You will go to input properties, you will hit with aluminum as well, and a thickness of 0.5. You will select OK. Then you will go to select application region, and you will select the web, that is this surface. And you will have the points 36 to 53, 119, 120, 122, and 123. You will select add, you will select OK, and you will select apply. You will have all frame web and the frame flange as well. So you will go to loads and BCS, you will go to load cases. Here you will change the action to modify, and you will select default in order to check that you have the displays fixed base, the force dead load, the force dead load 2, the force OP static load, and inert gravity. Here you will select cancel. And you can continue with your next step. You will go to group, post, and you will select fem surfaces. You will hit apply and then cancel. Then you will go to analysis. Is here. You will go to analysis deck because it's less heavy than a full check or the full run. You will go to translation parameters. You will change your card format to small. You will hit OK. You will check that your solution type is linear static. You will hit OK here, and you will hit apply. Okay, so you can go to your next step here. For the part of the analysis, you need to go to your folder where you have your practice or the workshop you're working on. You'll have this PDF. In this case, you will need to open Nastran, and you will select here in workshop number 6. You will select this PDF, and you will hit open. You will hit run, and it will select, and it will start running your Nastran. You'll need to wait a few seconds or maybe a few minutes in order that it's working. It's processing all the information you're given. So here I have an antivirus. You will create an exception and it will run. You can see here that you're having all these folders or these documents that will erase in a minute. The things you need to check here are your F06 and your F04. In this case, you need to check your F06. In order, you need to put fine, and you need to look for warnings. Warnings is the first thing you need to look for. So you have warning, you only have one warning, so you're okay. The next thing is fatal. Fatal is the thing that can bring your program. We don't have any fatal, so we can check it. So then we will continue your pattern as well. You will go to results. First of all, you will to analysis. You will put XDB, and you have here the X result attach XDB and result entities. You will have that available jobs is in the job you were working on. You will select result file, and you will have the XDB that Nastran create. You will select apply, and is that it's attached in a result file. So you can go to here to results. You will go to create. You will go to deformation, and here you will select displacement translational, and you will have position non-layered, and you will select your model scale, going to this tab that is displace attributes. You will have the scale factor of 0.01, and you will then check the show on the form on the mark, and you will select apply, and then you will go as well. You will put here, and you will hit apply as well. You can see here how it's changing, how it's changed. You will make like a bending, and then you go as well here. You go to create. You go to deformation, and you put over here as well on the displayed attributes. You will select render style. You will select shaded, and then you'll keep the same things we talk about it, and you'll hit apply. You can see how it is shading and how it's changed. And then for your next step, you will go to create, but this time will be a French. You will select the last thing here. There's a stress tensor. You have a position that is at C1, or if it is non-layered, you will select that and you put at C1, and then you select the bond misses and you hit apply. You can see here all the colors and the maximum and minimum information, and then it will look like the following. Here you have it. Here is how it's looking. So we go to home and you select the reset graphics in order to have it like a wireframe, and then you'll go to create as well. You'll go as an object will be a marker, and will be a method will be a tensor. You'll have stress tensor. You'll have the position at C1 as well, and you will only mark XX and X and YY. The other ones you can mark uncheck them. You will go to display attribute that is here, and you will uncheck the show max min label and the show tensor label. You will uncheck them, and then you will go to plot options. That plot options is the right next one to display attributes. You will have it at assist, the coordinate transformation. You will have it as assist, and you will hit apply. As you can see here are the markers X, Y, marking to all the directions we're having, and that is transformation we're having of the stress. We will go as well to reset graphics here in home. You will go to feed view in order to see the complete thing. You will go to plot options as well. Here you have it, and the coordinate transformation will be global right here, and then you will hit apply as well. You can see here now it changes because it is comparing with the global that you used to create a plot. This means that the stress components are displayed in the MSC Patran global coordinate system. So here, don't forget to save it in order to have it for future reference. Thanks for watching. My name was Marisa Mundi. I'm from State University in Student Mechanical Engineering 6th semester. So don't forget to leave a like, give any feedback you have, and thanks for watching. See ya.